Hey guys, Jay here with Word of Advice TV, and lately on my furnace videos I've been getting a lot of comments of how to test an inducer motor. Inducer motor is not working, inducer motor is not getting power, it's noisy, it's hot, it's stuck, inducers. So I finally decided to make a video solely on the inducer motor, and hopefully I will cover all of that in this video. So let's go ahead and open up our furnace here and take a look at the inducer motor inside of this carrier high efficiency furnace. So right here we have our inducer motor assembly. If you were to replace this, you wouldn't replace just the motor, you would replace this whole assembly. So the plastic housing along with the motor. And of course the purpose of the inducer motor is to push the combustion gases or the exhaust gases out through this exhaust pipe to the side of your house. So let's start with a noisy inducer motor. So if your inducer motor is noisy while it's running, the first thing I like to check, if I come out and, first of all, I would set the thermostat to heat so it turns on, and I'll watch this thing turn on. And if it's like rattling and it's noisy, the first thing I want to try doing is pressing on the housing of the inducer motor, just in different spots, and see if that affects the rattle at all. If pressing on the housing does make the rattle or the vibration noises go away, then you know that most likely something is just loose. You could try tightening up a screw or all the screws that are around it, or you could try to shim it a little bit to make that noise go away. But keep in mind, if you have an 80% furnace with the steel vent and a metal housing, if your furnace was just running, that housing will be extremely hot. So don't burn yourself pressing on it, or put some gloves on it, or just wait for it to cool off before you start touching that housing. Now this is a new carrier furnace, but the old 80% carrier furnaces, they had a different style inducer motor that had like a triangular metal plate behind them that it was mounted to. And oftentimes I would see inducer motors get replaced, and all that was wrong is those grommets. There's 3 black grommets on that old style inducer motor. Those grommets wear down, and that's what causes the motor to rattle like crazy. So really, on most of those older style carriers, all you gotta do is replace the 3 grommets, and that will make the noise go away. Another reason why the inducer motor may be noisy is because maybe perhaps a bird got in there, or some nesting from a bird, maybe a rock or a pebble, anything that can come down the pipe, because these pipes are generally going to be on the side of the house, the intake and the exhaust. Both of these white pipes are going to be on the side of the house, or maybe you have little kids, if they threw some stuff down there, it can eventually end up in the inducer motor housing. So you got the cooling blade on the outside here. It basically cools off the motor as the furnace runs. But on the inside, you got the actual blower wheel that pushes the exhaust fumes out. And that blower wheel on the inside would be making a lot of racket if some stuff got in there, or it would get stuck altogether. And the last reason is that the bearings on the motor are starting to get shot. If the bearings are going out and it sounds like a loud grinding noise every time your inducer motor turns on, and it's none of the stuff that I listed before, then that simply means that your motor is starting to go out. Now granted, I have seen noisy motors run for years before actually going out, so I don't think it's an urgent situation, if you have a noisy inducer motor, to have to replace it right away. But just as a precautionary measure, I would probably order an inducer motor and at least have it, by your furnace, just in case that thing does die out. And the next thing I want to cover is a stuck inducer motor. It could be seized up, it could be jammed, or the motor could be bad altogether. So the first thing I would do to see if it's stuck or not, I would open up the furnace and I would just spin the cooling blade and see how it spins. See how mine spins real easy and it just keeps spinning and spinning and spinning? The cooling blade in front should spin very freely, like mine is right here. Now, not all furnaces will have a cooling blade in front of here. So if you don't have a cooling blade in front, a lot of times you could just take a flathead screwdriver and reach in the middle here and spin the blades. There'll be another little wheel there. You can reach in with a little screwdriver, either in front, there will be a blade underneath a grate, or in the middle. Just reach in with a little screwdriver and push that blade and see how well it spins. And there are some older inducer motors that will not have any fan blades in the front at all, in the front of the motor. It's only stuff inside. In that case, what you can do is just take a needle nose plier and just grab the shaft in front and spin it that way. So if your inducer motor is spinning freely, the cooling blade or the shaft or whatever fan blades that you're spinning, if they spin free, then you know that the inducer motor is not stuck. But If you go to spin the wheel and it's all really crunchy or grindy, that likely means that your motor is shot or there is something jammed inside of it. Once again, a dead bird or some nesting. And the only way to verify the latter one would be to pull the inducer motor out. I'm not going to do that right now, but just as an example, at the end of the video, I will pull this inducer motor out just to show you how to do it and what the inside of it would look like. And if you came to your furnace and the inducer motor was stiff to begin with, but as you spun it a little bit, it freed up and it started spinning better, in that case, a lot of times what happens is as the furnace sits there all summer long and it doesn't run, the first time in the season, the motor can get a little bit stuck. And you free it up and it starts to go, and after that there's no problems for the rest of the season. But if you're less fortunate and no matter how much you spin your wheel, it's still very stiff, it doesn't free up, then what you could try doing is oiling that motor. Most new motors will be permanently sealed, so they don't have oiling ports. Only really old furnaces will have an oiling port somewhere in front, a little hole where you could stick the zoom spout oiler bottle and stick the spout inside of that hole and oil it that way. Only very old furnaces will have that. The newer furnaces will all come with the bearings all sealed up, so there is no oiling ports. But what you could try doing is sticking the zoom spout oiler spout behind here between the housing and the motor and try to oil the shaft where it goes into the motor. Of course, to do this, it does help to pull the motor out and then oil it so that the oil seeps in down the shaft and into the bearing. And after you oil it, you just start spinning the wheel to try to work as much of that oil inside as you can. So, I do that quite a bit during the winter just to get customers by. But usually, if a motor is seized up and you can get it freed up and going by oiling it, typically it will still seize up again in a week or two, or if they get lucky, a month. It's very rare that oiling it will be a permanent solution. Okay, enough about that. Let's move on to the next scenario. Let's say your wheel spins freely, and sometimes you can even hear it humming, like it's trying to start, but the motor is not starting. That is usually a bad sign. That typically entails replacing the motor, especially if you put your hand on the motor and it's scorching hot. That is a bad sign. Another thing that could cause it is a dead capacitor. You could replace the capacitor and it'll probably work, but by that time, because it was trying to start all those times, the motor is probably damaged, so it's not going to last long anyway. So I would still recommend replacing the whole inducer motor assembly. But in a little bit, I'll show you how to check the capacitor as well. And lastly, if you're smelling a burnt electrical smell coming from your inducer motor and it's not starting, even though it's humming and it's hot, then almost guaranteed that you have a bad motor, the windings are starting to melt, and you just have to replace this whole assembly. Okay, so all the previous checks did not require a meter. You can check all of that without anything really. But for verification, to know 100% if it's bad or not, you do need to have a meter. A digital multimeter to check it. So let me first show you how to check voltage at the inducer motor to see if it's working properly or not. So the way the sequence of operation works on a furnace, your thermostat calls for heating if you set it to heat and you increase the temperature. And after the thermostat, the very first thing that turns on in the furnace is the inducer motor. So if your thermostat is calling for heat, but the inducer motor is not coming on, then either the motor is bad or there's an issue with your thermostat or the control board. So an easy way to check that is to find the plug where the wires go to the inducer motor. So here I have all my wires going to the inducer motor. They go into this plug right here. And if you notice, usually on most inducer motors, there's going to be a ground, a black, and a white. But mine also has a red. And the reason I have that red wire is because this is a two-stage furnace. So this would be the high stage, and this would be the low stage. But regardless of what furnace you have, if it's a single stage or a two-stage, you would be checking it from the white wire to the black. Because even if you have a two-stage furnace, it momentarily starts up from the high stage and then goes into the low stage. So you would stick one lead into the white and one into the black. And if your thermostat is calling for heating, your inducer motor should be getting 120 volts. So I have my furnace power switch off right now. Let's try turning it back on and see if we have a call for heat. And because this is a carrier furnace, whenever you turn the power switch off and on, the very first thing carrier furnaces do is turn the blower motor on for 90 seconds before it does anything else. It's like a pre-purge cycle. Okay. So my inducer motor turned on, and as you can see, I'm getting 120 volts. So I'm going to go ahead and turn the power back off. So if you're getting 120 volts going to the inducer motor, but it's not turning on, then you know for sure that the motor is bad or the capacitor is dead. But what if you're not getting 120 volts going to the inducer motor? In that case, the next step I would take is to go down to the control board, which is going to be on the bottom here. And when you take that bottom door off, there's going to be a door switch underneath the bottom door. So I'll just show you mine right here. There's a door switch that disengages and it cuts power from the furnace. So for testing purposes, when you take the bottom door off, you want to keep this door switch closed. I just use a piece of sheet metal tape to keep it closed so that we can do our tests with the power on. So I'm going to go ahead and turn my furnace power switch back on. And as you can see, I have lights right here. If you're seeing any blinking LED lights on your control board, that means that your furnace is getting power, and that means your transformer is okay. But if your furnace is getting power and there's no LED lights on, that might mean that either the control board is bad, or the transformer is burnt out, or for some reason the furnace is not getting power at all. Okay, so I turned my furnace power switch back off, and of course it's best to verify with a meter if you have voltage or not, especially if your control board does not have any LED lights. So I set my meter to voltage, and you find the thermostat terminal strip on your control board. On this one it's kind of weird. Usually it's just one strip, but these two are divided. So what you're looking for is R, W, and then also common, which is right here. So to test if your board is getting 24 volts from the transformer, it's actually going to be more like 24 to 28 volts. You would put one lead on R and the other lead on common. So let me turn the furnace power switch back on quick and just show you what that would look like. And of course, because I cycled power, the blower motor is going to come on. I always turn it off because it's kind of loud and interrupts when I'm talking, but we'll leave it on this time. So if I go from R to common, that will tell me if I'm getting the proper voltage to the control board. As you can see, I'm getting 27.6 volts. So if you have 27 volts between R and C, or if your LED lights are blinking, then you know that the transformer is good and the furnace is getting power. The next thing I would do is rule out the thermostat, and to do that, you have to jumper R to W. So here's my R and here's my W. So while I'm jumpering R to W, you want to have the furnace power off. So I turn the power switch back off. I'll put one alligator on R, and I'll put the other alligator on W1. And I have other videos on how to jumper the thermostat or bypass the thermostat at the control board and at the thermostat itself, along with a video on thermostat wiring. So if you want more info on this piece of it, just go ahead and check those videos out instead. So by having a jumper from R to W, I'm basically bypassing the thermostat. And if I turn my furnace power switch back on, that will start my heating cycle. Okay, so I turned the furnace power switch back off so you can hear me better. But basically, if your power is on, if you have a jumper between R and W, the LED lights are blinking, that means you should be getting 120 volts from the control board to your inducer motor. So you can either check it by backstabbing it like this, or you can just unplug it. The whole plug going to the inducer motor. and stick your meter leads inside of the plug. But if you're doing it this way, just be careful not to damage the pins inside of the plug. Don't jam your meter leads in there. If you bend them, then that's usually a bad day. It's really hard to try to bend them back, or you end up having to replace the harness. So if you're getting 120 volts to your inducer motor, but it's not turning on, then the inducer motor is bad, or the capacitor is dead. Either way, I would replace the whole inducer motor assembly. But let me just show you quick how to check the capacitor if you wanted to check it. So first of all, you want to disconnect the wires going to it. Be careful not to touch the prongs because there might be a little bit of a charge still in them. You want to short the capacitor out to make sure there's no charge. And of course your power switch on the furnace needs to be off. Short it out like that. Then set your meter to microfarads. And most inducer motors will have a 5 microfarad capacitor on them, but there are sometimes a different size, and they should be within 5% of that 5 microfarads. So plus or minus 5%. So if I put my leads on this capacitor, sometimes it takes a while to load up. Mine loaded up real quick. It's 4.98. So my capacitor is good. And you've probably already noticed, but this capacitor does not look like a regular cylinder silver capacitor. The ones on the inducer motors, let me just take this one out so you can see it better. They're just like a black little box. And on this side of them, right there, the 5UF, that's the microfarad rating. And like I said, almost all of them are going to be 5UF, 5 microfarads, plus or minus 5%. So if, for example, your capacitor is only reading 1 microfarads and your motor is getting 120 volts but it's not starting, then chances are that's because of this capacitor right here. Now, if you've caught this problem early on and your motor hasn't been trying to start for a couple days already, then you could just replace the capacitor and it should be good. But if the motor is really hot and it's been trying to start for days before you came out there to look at it, then I would recommend just replacing the whole thing because chances are that motor has been damaged by now. And one last thing about voltage, if you're getting low voltage, you know how I said it should be around 120 volts getting to the inducer motor? Let's say you're only getting 80 volts to the inducer motor. In that case, first thing I would go after is loose connections. I would try jiggling all the wires or try to push them into the plug a little better. You know, each wire going to the inducer motor and then at the control board itself. So for example, if I have my meter set to voltage, you know, and I have a lead here and a lead here, instead of getting 120 volts, let's say I'm getting 80 volts. In that case, most likely you have a bad control board if there's no loose connections. And the way you would check that is to find your transformer, which in my case is right up top on the control board right there, above the control board. Just see where the primary windings wires go. It's usually going to be a black and a white, which is going to be around 120 volts. See where these two wires go. In my case, one goes right over here on the bottom, and then the black one goes to the right of that. And I'm not going to do a close-up of this, but basically what you would do is stick your meter leads under 2 of those terminals and see if your control board is getting 120 volts. So if there's 120 volts there, but there's only 80 volts going to the inducer motor, then most likely your control board is bad. So if it's getting 120 volts in, but it's only sending 80 to the inducer motor, you got a problem with the control board. Okay, and after voltage, the next way to check the inducer motor would be to check resistance. That's to check if the electrical windings inside of the motor are good or not. So you would set your meter to the horseshoe symbol, resistance, and when you're checking resistance, the power needs to be off and the wires need to be disconnected. So this plug right here from the inducer motor would have to be disconnected, or in other words, completely isolated. And if I check resistance between common and my hot wire, or basically this would be the high stage, this is the low stage, I should have some kind of resistance, probably somewhere between 40 to 100 ohms. So if we take a look at my meter, I have 86 ohms, or 86.7. And different motors will have different ohm readings. It could be 40, it could be 90, it could be 60. Different motors will have different readings. But basically what you're looking for is some kind of an ohm reading. If you get OL, that means you have an open winding somewhere, it's burnt out. Or if you have 0.0, that usually indicates a direct short. So I have a good ohm reading for my high stage. If I check the red wire, which is going to be my low stage, let's see what I get there. And this inducer motor is good, so I should be getting good readings. So as you can see, I'm getting 30 ohms, so that winding is good as well. So if you get ohm readings like that, you know your inducer motor is good. What you don't want to see is OL, or 0.0. Another thing you can check is from power. So let's say the black wire, the hot to ground. From hot to ground should always be OL on both the red and black wires. There should be no continuity between the hot leg and the ground. Well guys, and that is how you check an inducer motor with a meter. And there's two more things I want to touch on before we wrap this video up. One of them is, what if the inducer motor is running all the time, non-stop? It's not turning off. Regardless if the burners are on or off, the inducer motor just keeps running. Usually, that's a bad control board. And if that's happening to you, the first thing I would do is disconnect the inducer motor. You don't want it to be running all the time. They're not designed to be continually running. So if it's going to be running like that for days on end, that motor will burn out. And like I said, likely it's a bad control board, but the inducer motor may be running because some safety limit is tripped, like a flame rollout, for example, or a high limit. I have seen some furnaces where if a safety limit is tripped, it will run the blower motor continually and the inducer motor continually until that safety limit problem is resolved. So likely it's a bad control board, but before you make that conclusion, check for any error codes or lights flashing on the control board to see if there's any safeties that are tripped. And the next problem is the inducer motor turning on and off. So it'll only turn on for a couple seconds, turn off, turn on, turn off. Usually that is either caused by a loose connection somewhere, or oftentimes I've seen the cause of that be that the pressure switch is just opening for a split second. So it closes, but then opens for a split second and closes back up. That causes the inducer motor to have that lag or the stutter where it turns off and turns back on. And out of the times where I had to deal with something like that, oftentimes it was the pressure switch. And the thing is, it trips so quickly and then it closes back up that the meter does not pick it up if you're measuring it with a meter. So in those cases, a good test is to jumper or bypass the pressure switch. If the inducer motor runs without stuttering, with the pressure switch bypassed, then you know that there's something wrong with the venting. Either it's not venting correctly, something's wrong with the inducer motor blower wheel, or maybe there's some nesting or some other stuff in there. But until that venting issue is resolved, it'll likely keep tripping like that. I have a video of 10 reasons why a pressure switch can trip. Maybe one of those reasons can help you. And I also have a video where I talk about 3 ways to troubleshoot a pressure switch. So if you need more info on the pressure switch side of things with the inducer motor, check those videos out. But I do want to underline that if you ever bypass or jump a safety switch, that should only be done for testing purposes. Do not ever leave a pressure switch or some other safety switch bypassed. And as promised, let's go ahead and take this inducer motor out and take a look at what it looks like inside. Before you take it off, you're going to have to probably take some wires apart. For the wiring, it's pretty simple usually. You just unplug it. And then there's also pressure switch hoses or tubing. You want to take some of that off as well so nothing is obstructing it when you're pulling it out. Do remember where you pulled this off from though, or take a note or mark it so you remember where to put it back. So I got that disconnected, and then my pressure switch is probably going to be in the way as well. I'll just take this assembly off. Okay, so we got the pressure switch out of the way as well. And now we are almost ready to take it off. I'm also going to take the venting off right here, this boot. And I think to do that, I will just loosen this guy up right here. And I will also loosen this screw on this side. And try to pull this boot off of the inducer motor housing. And usually I don't pull it completely off. You don't want to mangle it or make a crack in it. So after it's nice and loose, when I take all the screws off from the inducer motor housing, I should be able to just swivel it out. And now for the final stretch, I just have to take out all the screws holding the inducer motor housing. And I think that's all of them. And I should be able to just pull my motor right out. And like always, you forget at least one screw. There's one hidden underneath. Okay, let's try that again. Well, that one took a little bit of persuasion, but with enough wiggling, I was able to get it out. And here is what this is a high efficiency furnace, so it has some water in it. That's where the dripping is coming from. Here's what the inside looks like. And the impeller on the inside is just a plastic fan. So sometimes if some kind of debris gets in there, or a pebble or something, this impeller will actually break into pieces. And if the fan inside is broken, then there's really nothing you could do but replace this whole entire housing. And one more thing I want to point out is that, especially on older furnaces, when you pull an inducer motor off, this gasket right here is probably going to be all mangled, or it'll be completely ripped off when you're taking the inducer motor off. In that case, when you're putting the new inducer motor back on, or if you're putting the old one back on, make sure that you take some high temp silicone. For example, if this gasket was damaged right here, this red one right here, I would completely, pluck the rest of it out and then fill that space in with the high temp silicone before I put this inducer motor back on, so that there's no exhaust fumes leaking out, and that could also cause pressure switch problems. Well guys, I put it all back together and I did not even have any leftover screws. And that's actually all I had for you today. I hope you found this video useful, and I know I didn't touch on variable speed inducer motors, and I did that on purpose because most of those variable speed inducer motors, you have to go per manufacturer procedures to test them, and each brand is different. You just have to refer to the manual on each one of them. So I didn't really go into that. But that being said, out of all the variable speed inducer motors that I've replaced, and I've replaced quite a few, almost every time it's pretty actually simple. If the inducer motor is getting power but it's not starting, then the motor is bad. Those variable speed inducer motors, they don't have capacitors, so that's not even a variable. If it's getting power and it's not turning on, it's not spinning, the thing is bad. So I hope this will help your inducer motor troubleshooting. And if you have any further comments or tips or suggestions, anything inducer motor related, please share with us in the comments below. Thank you so much for watching this video. Don't forget to mash that like button on the way out, and we'll see you next time. And if you're still here and not in the comment section below, did you hear the breaking news from Japan? This must be a new trend. Glass coffins. Will they become popular? Remains to be seen. Stay tuned.